automated beverage dispenser, just sitting right there. Okay, so problem statement is to design and build a more efficient device for dispensing alcoholic beverages in bars, clubs, or pubs by using an Arduino-controlled design. My device aims to simplify and speed up the process of getting a drink to the customer, therefore increasing profits customer quicker. So get it to the customer quicker. Okay, so my project aims to decrease the spilling of drinks. When bartenders are put under a bit of pressure, they tend to sort of look around and pour drinks everywhere. Increase accuracy with the mix that is poured, so you'll have a perfect ratio of, say, brandy and coke, which will then in turn make it taste nice as well. No mixing up of drinks. Bartenders, once again, put on a lot of pressure. They could grab the wrong drink. With this, you just need to put it underneath and it'll have the drink already, do it for you. This puts less stress on the bartenders and even the customers or consumers. Get that perfect tasting drink every time. It is very compact, very small, and simple to use. And it is affordable for smaller sort of operations like bars and clubs where it's small space, lots of people. Okay, so some project research that I did, current ideas and implications. So as we all know, there's a conventional water dispenser, which has a large reservoir at the top, uses gravity, and then you can push the lever down so that the water comes out. Right there. And then I also did some more research and found that people have made homemade automatic dispensers using distance sensors, which was what I originally based my design on, but decided to scrap that because it wasn't as accurate. And then there's the smart tender, which is what I will be competing against. I'll get more into detail here. Okay, so that's pretty much what the smart tender looks like. I'm going to name some disadvantages of this. As you can see, it is very large, lots of smaller components. It's expensive because it has so much technology in there and it is so big. There's no drink at the click of a button, so you've got to press a whole bunch of different things just to get one drink. And because it's so large, it is also difficult to maintain all the smaller components and whatnot. And you actually also cannot buy these, you have to lease them, which is also good fun. Okay, getting on to my design project, here's a little bit of an index of how the next slides will look and how my design project actually, all the steps I took to complete it. Here's a bill of materials. So, use an Arduino shield, the load cell amplifier, electric wires, acrylic, printed 3D parts, 2 servo motors, 2 ball valves, some pipes, an RGB LED strip, and button, which amounted to about 1,500 Rand. Okay, a little background as to what a load cell and amplifier is. So the load cell measures electrical resistance in response to strain applied to the device. Fine line and grid pattern, so there's a linear change in electrical resistance when the load cell is put in the strain. And then the amplifier is there to increase the signals and converts it to an output value created by the strain gauge on the load cell, so that the values can be accurately read in the program when there's 0 monitor. Okay, so starting my design process, I drew up some rough sketches. As you can see here, I had my distance sensor, which I've scrapped and changed to load cell, just the bottom there. I also, here, I initially wanted to use some air pumps, but then I decided to just change that, scrap that idea and just use gravity, flow water. Then I went over to Solidworks and I made some parts and assembled them. There's the actual box where the electrical components would be, and the servo motors and the valves, and the reservoir as well. Here's an assembly of the reservoir, and then here's a little stand for the servo motors and the valves. And here's a little piece that I had to print to connect the servo motor and the valves together, so that I could open and close the valves. And then here's a my fully assembled beverage dispenser, just with the 2 walls taken out so that you can see inside. So obviously electrical components placed down here, servo motor, and then the valves. had to then assemble the valve opening mechanism, which you can see here. Here's that little 3D printed part that used to connect the servo and the valve. And then here's that little mount just so I can have a better flow of water. The water would flow. Yep. Then connecting all the electrical components, the full sort of assembly of it. Here's two of the main schematics. There's the servo motor, which is here, and then the load cell connected to the amplifier, and the amplifier connected to the Arduino. Then I had to connect all the piping. I did have to 3D print 4 little fittings for the pipes because I couldn't find a valve that was small enough to actually make the pipes fit. So I had to adjust to that. And then the T, pipes to the T here, so I have one output. Okay, so how my project actually works. The glass is placed on the load cell, which in turn opens the first valve. Then once that activated the first liquid, which in my case would be brandy, starts pouring, and the load cell weighs the amount that is in that glass. Once the desired amount of the first drink is in, which is set to 35 grams, once that first brandy's in, the second servo motor will open and start pouring out the Coke, which I have set to 300, the combined weight, the max weight of 300 grams, combined weight of 300 grams, and then that second servo motor will close again. Here's some of the programming I did. So glass is placed onto the load cell for reading the readings. Then once the glass is placed onto the load cell, servo 1 sequence starts. And then, so white for if the glass is just placed onto the onto the load cell directly, the LEDs will shine white. And if you click the button and then place the glass down on the load cell, the light for the brandy will shine blue. And then, so here's if the button's pressed, it'll double this amount here for the single and change it to a double brandy.
So you did implement it.
Yeah. And this is when the second servo opens. Both of them, they start at 105 degrees, move over to 160 degrees to open, and then detach and move back to 105 degrees to close. And the LED then switches to regulator when the Coke is being poured out. Okay, so some technical difficulties that I had. No major setbacks, a couple minor ones though. Having to make the valve fittings wasn't really a setback, but just an unnecessary adjustment that I had to do. Well, necessary, but it was a bit of a mission. Then changing my project from distance sensor to load cell. When I did change it to load cell, I thought I was not going to understand the whole process, just not, yeah. And then waterproofing everything was the main thing. From the beginning, I didn't count for the water leakage and all of that would occur. Okay, some lessons that I learned are definitely Solidworks was the main one. Richard telling me to assemble and make all the parts and whatnot. Then using more advanced Arduino programming, with the help of Chris, I managed to program all the LEDs nicely and get the bulbs working and whatnot. Then time management, a little bit of soldering as well, and I learned a lot about all the different electronic components. I have no idea what the load cell and the amplifier does before this, so that helped a lot. And to conclude, there are definitely more things I can to furthermore improve my project, like adding the air pumps to get a high flow of water. Definitely more waterproofing, that's what I need. And yeah, I'm very happy with the outcome, and that it can pour a nice tasting drink successfully and simplify the process of doing so. I did also learn a lot making my project, had some ups and downs, but managed to make a product that I am very satisfied with. Thank you.